Now we are going to discuss about the electrical properties of colloidal dispersion. Optical properties completed, kinetic properties completed. Next one is electrical properties of colloidal dispersion. Under the electrical properties of colloidal dispersion, we are majorly discuss about the effect of electrolyte concentration and zeta potential. First one is effect of electrolyte concentration and second one is zeta potential. Now the first one is effect of electrolyte concentration. Effect of electrolyte concentration. So effect of electrolyte concentration. What will be there means, see, I have taken one NaCl, here one NaCl. So when I will add this one NaCl to the lyophilic salt or lyophilic colloidal system, then this, forgot about the sodium, the chloride ion will remove, means one chloride ion will remove one solvent film. These are the solvent films. These are the solvent films, like 1, 2, 3. 3 solvent films are there. Around the lyophilic colloidal particle, 3 solvent films are there. So first I need to remove the solvent, means in order to make unstable means there is in order to form the precipitation of this lyophilic colloid, then I need to remove the solvent film from this colloidal particle. I need to remove the solvent film. So just I have added only one NaCl. Then this chloride will remove only one solvent film. Then I will add another NaCl, second solvent film removed. Then I added another, means third NaCl. Then that is remove the another solvent film. So in order to remove 3 solvent film, 3 NaCl are required to make unstable of lyophilic colloid. In order to make the unstable of lyophilic colloid, how many more concentration? See, the more concentration, 3 NaCl means more concentration of electrolyte is needed in order to make unstable of this colloid lyophilic colloidal dispersion. But now consider, in case of lyophobic colloidal dispersion, just I have added only one chloride NaCl, one salt I have added. Then the chloride is there, now this chloride will react with gold. This is lyophobic colloid. This chloride will react with gold, then immediately settling of or formation of PPT. So see, now you can compare. Only one NaCl or one chloride ion is enough to make unstability of this lyophilic colloid. But here there is a 3 requirement of how many? 3 requirement means 3 chloride ions are required to make unstability of this lyophilic colloidal dispersion. So which is high sensitive means this lyophobic colloidal system is high sensitive due to no solvent film is there. This is lyophobic colloid is more sensitive to the electrolytes because there is an absence of solvent film. So just one NaCl is enough to make unstability of the colloid. Here 3 NaCl is required to make unstability of the colloidal dispersion. So which is more sensitive means high sensitive. Lyophobic colloid is more sensitive compared to lyophilic colloidal dispersion. So how now the pharmacist what we can do means, how can I stabilize this? How can I stabilize this lyophobic colloidal dispersion? This is okay. This is the lyophilic colloidal dispersion is stabilized. Whenever the more concentration of electrolyte is there, then only it will become unstable. See, in case of this lyophobic colloidal dispersion, a little amount of electrolyte will cause unstability of this lyophobic colloidal dispersion. So why we are discussing this majorly means water contains electrolyte. water contain electrolytes. So these electrolytes, the electrolytes which are present in the water, that will easily unstable the lyophobic colloid compared to the lyophilic colloid. So water contains electrolytes. Electrolytes means ions, NaCl, chloride. Like ions are there. These ions immediately make instability of this lyophobic colloid compared to the lyophilic colloid. So how can I stabilize the lyophobic colloid? This is a major concern or major problem associated with lyophobic colloid. So pharmacist what he has designed or what he was thought means, the pharmacist has developed one method that is the protective action. So if this is a lyophobic colloid, once I will protect this lyophobic colloid with lyophilic colloid. Once I will protect this lyophobic colloid with protective colloid or lyophilic colloid, then I make this unstable, I make this lyophobic colloid as a stable colloidal dispersion. See how means, just simply, this is gold. Then I have added what? Lyophilic colloid I have added. Then what is there around this lyophilic colloid? There is a solvent film is there. Solvent film are there around this lyophilic colloid. The solvent films are there. When I add the salt NaCl, then this NaCl first need to remove the solvent film. First it need to remove the solvent film from this lyophilic particles, then only it attaches to the, see, first this NaCl is there, first it need to touches these layers, this layer. Then after that, then it will reaches to the lyophobic colloid. First it need to reach the lyophilic colloid, after that it need to reaches to the lyophobic colloid. So in order to make instability of this lyophilic colloid, first it need to make instability of lyophilic colloid. So I have protected this lyophilic colloid by using lyophilic colloid. This lyophilic colloid also called as a, here in this case this lyophilic colloid I will call as a protective colloid. Why this protective colloid means, this lyophilic colloid protecting this lyophobic colloid from the unstable, means from this chloride ion. This lyophilic colloid protecting this lyophobic colloid from this NaCl or electrolyte. Hence we are calling as a protective colloid. This is the mechanism of protective colloid. So this is about the electrical properties and effect of electrolyte concentration on the instability of lyophilic and lyophobic colloid dispersion. So water generally contains, water itself contains electrolytes. These electrolytes immediately make this instability of lyophobic colloid. That's why we are majorly using, or we need to stabilize this lyophobic colloidal dispersion by using protective colloid.